the day. Sum of nodes within k distance from target. So Geek is at the Geek Summer Carnival. To unlock discounts on exclusive courses, he is given a card with a binary tree. Okay, we are given a binary tree, a target node, and a positive integer k on it. He needs to find the sum of all nodes within a max distance k from target node such that target node is included in the sum. So what all we have? Okay, so what are we have? We are given a tree. Okay, some tree. We are given a target. Okay, and we are given a value k. So this target will be somewhere inside this tree. Okay, and we need to include this plus all the other nodes that are at the distance of k within this range of k. It can be less than k but not more than k. So all these values has to be added. So this the simple what we need to do. We need to find the target. We need to identify those nodes that are with at least k distance. Okay, at most k distance, then add them together and return the sum. So that's only what we need to do. So there are certain things that we actually needed here. So let's consider this 1 2 9 4 5 7. Okay, 1 2 9 4 5 7 2 9 4 5 7. Actually it was this 5 was here, this 5 was here. Let's have the given example itself. Okay, now 8 19 20 21. 8 19 20 then 21. Again I missed the thing. 20 21. Okay, now have 30 40 50. Okay, have 30 40 50. So first of all, we are also given with target which is 9. So target is 9 and what is our k value? K is 1. Okay, k is 1. So first thing what we need to do is we need to find the target, where this target is. Okay, so is 1 is equal to 9? No. 2 equal to 9. We can make use of a tree traversal in order to locate where this 9 is. Here our 9. So what are the nodes which are at least a distance of k? So we have this one. Okay, we have this one 5, we have this one 7. So all these nodes are at the distance of 1. So what will be sum? 1 plus 9 10 plus 5 15 plus 7 22. So one thing to note is that 1 is the parent of this 9. So there is also one more requirement that we need to consider. We also need to find the parent of the node. So that's one requirement. So we will be finding the parent of the node. Then from the target node we will be going to all the nodes plus all its children node plus to the parent node, which can be obtained from the data structure that we are using. We can make use of a hash map. So here what it looks like means for 9 the parent will be 1. Okay, so in all together, like we will be going to this 5. Okay, there is 5. We will be doing the tree traversal to this 5 adding that into the sum. We will be doing the tree traversal to this 7, adding that into the sum, and we also will be adding to 9, but we will be missing this one. So for that, what we done, we have also tracked their parent. So 9 will be tracked to 1 or mapped to 1. So we will be also doing a DFS into this place, because in normal normal tree traversal, like we will be going downward or we will be going level by level. There is no like a moving back kind of a thing, not to get only like we will be backtracking, of course, but this like we are just moving back. So that's what we need to do. And after moving back, there is a chance like we again coming here, we again going here, we again going here, again taking this one and this one, and again repeating this process, which ends up in a infinite loop. So for that, we need to track all those nodes that are visited. If a particular node is visited, there is no point in again visiting in that, because after that we will be visiting their children and that node's parent. So we will be also maintaining a data structure in order to track the visited nodes, and for that as we can guess, a hash set will be more suitable. And for tracking, for mapping this node to parent, a hash map will be more suitable. And for this question, like I will be taking the sum as a global variable, and also I will be locating the target node and will be storing into a target node variable, and I will be also taking that as a global variable, even though it's not a good practice in order to take all these values as a global variable, but let's go with that. So let me have private int sum, okay, and private node target node. So for every kind of a tree, it's always better to go for the null check out first. So if node is equal to null, we can return 0. Now let's have our sum is equal to 0. Initially we didn't found our target node, let it be null. So what are the extra requirements what we need? We need a node to parent mapping. So map of node comma node to parent is equal to new hash map. Now what is the requirement that I mentioned at the very end in order to get rid of this loop, in order to maintain a visited data structure? So for that we can make use of a set. So set of node visited is equal to new hash set. Okay, now first of all we will be filling this node to parent, and we will be finding the target node at the same time. So fill the node to parent map, and for that we need to pass the root. And initially for this root there is no parent, so we will be saying like null is the parent for this root. Now our target value, okay, now we need to fill this hash map, so I'm also passing that node to parent. Okay, now after that, like we will be filling this node to parent, and we will be also getting the target node, because I will be also adding that particular condition. We can also add that particular condition inside this method. Like if the current node's value is equal to the target, we can set target node is equal to that particular node. Now what we need to do means, now we need to find the sum. So find the sum, and we will be starting from the target node, and we will be passing the k, we will be passing the hash map, okay, and we will be passing the visited, and at last we will be having the sum. So I just declare it as a global variable. In order to get rid of this, there is also one thing that we can do, like we can pass it as an array inside this method, so we can get rid of the sum as from the global variable, but it's fine. Let's go with this. So static void fill the node to parent map, and what are the values? We have a node, we have a parent, okay, we have the target value, and we have our hash map node to parent. Okay, so here also just make sure, as we are doing a kind of recursion retraversal, just do check, go for the null check. It's just the basic idea or the base condition check. Now if our node dot data, because that's what our node data structure is holding value, so node dot data is equal to the target. Let's have our target node is equal to node. Okay, now we will be putting the value, that is node to parent okay, node to parent dot put of the current node comma whatever be the parent. Okay, now we will be doing the DFS. So this kind of, we will be traversing the root node, then to the left, then to the right. So it's kind of node left right, kind of a pre-order. So remember, it's a pre-order, root left right. Yeah, so now just visit the left child, and now the parent has to be changed with the node, because for 2 and 9 1 is the parent, for 4 2 is the parent, for 8 and 19 4 is the parent, for 30 40 for 30 8 is the parent, for 40 and 50 19 is the parent. So that's the basic logic that we every time we apply. So target, now node to parent. Okay, now do the same for the, we need to also go for the right child. So node dot right comma node comma target comma node to parent. Now we fill the hash map. Now we have the mapping between the node and the parent. We know which is the target node. So now we will be starting our next traversal from that target node. And one special thing that we need to add is, we also need to go to the parent of this target node. So for that we will be making use of a hash map. So that for that reason, like why we made use of the hash map. So static void find the sum, we got the target node. Okay, we got let's say it's just node. Okay, so we have k, now we have the hash map node to parent, we have the set in order to keep track of the visited node, because in this case itself, like we will be visiting 5, okay, we will be visiting 7, we will be visiting 1. Now from 1 we will be again coming to 9. Now from 9 we again goes to 5, we again goes to 7. Like that kind of a loop might occur. So in order to get rid of that, in this case itself, if you go to 2, it will be more than the k, distance k. So we just neglect that. And if we go to 9, this is already visited, it's already visited, present inside our hash set. So we also neglect that. So that's the reason why we are making use of this visited hash set. So it's a retraversal. Go for the base condition for the null check. We just do return. If our k become less than 0, it means it's having more distance greater than k. That time also just return. If we already visited, if visited dot contains of node, just return. Otherwise update our sum with whatever with the node data, add that node into the hash map. Now go to left, go to right, and go to the parent. Okay, so find the sum of node dot left k, okay, node to parent, and this k will be decreased now. Okay, node to parent visited. Okay, we gone to the left. Now find the sum. Node dot right k minus 1 node to parent visited. Now we also need to go to the parent of the current node. So find the sum of that can be obtained from node to parent. So node to parent dot get of node comma k minus 1 node to parent visited. So that's it. So while telling about the space complexity or time complexity, for this fill the node to parent map. For this method we are going through all the nodes of this route. Okay, so it will be big of n, big of where n is the number of nodes, and space complexity will be the height or big of n itself, because we are making use of this hash map. We are filling the hash map, and that hash map will contain maximum of n number of nodes. And this find the sum. In the worst case, this can also have big of n. Okay, suppose we are looking for the target 50 and our distance is somewhat like 1 2 3 4, somewhat like 4 or 5, consider something like that, or more than that, 5 6 7 8 or 9. So in that case we need to traverse the whole array for this find the sum method also. So that case also the time complexity will be big of n, where n is the number of nodes, and space complexity for this method will be big of height of the tree plus big of n for the node to parent and visited. So the overall time complexity will be big of n, where n is equal to number of nodes, and overall space complexity will still be big of n, which is also the number of nodes that will get stored inside this hash map visited array, plus some auxiliary space for the recursion. So let's run this. Okay, where is that? 122. Okay, it's root. It's my mistake. Okay, it has to be static. Everything is static. So static. Let me also check, are there any other? Okay, it's only saying about the static. Okay, so this has to be static because all the methods are static and only the static fields can be obtained inside that. Yeah, so this is giving correct answer. Let's submit. So yeah, so this is the sum of nodes within k distance from target. So just briefing about the step, just have a node to parent mapping, just have a visited array, because while finding the sum we not only visit the child, we also go to the parents. So while visiting that parent, if you reach the parent node, we again have a tendency to come back to its children, which will lead to a kind of a cycle. So in order to get rid of that, we can also track the visited nodes now. So that's it. Like that's only what we are doing here. Okay, so we will be going to the left, we will be going to the right, and we will be also going to the parent node. So that's sum of nodes within k distance from target.